And thank you, dear colleagues, for being here, because Venice is very competitive. And I'm going to try to introduce you new strategy in sample preparation and also challenges in instrumentation. So, this is what I should not do. It doesn't move. Just a second.
To nějaký ten starý fotografický třeba.
I'm sorry. Looks. Okay, sorry. So, it will be funny. Okay, now. So my institute is in Prague, very old institution, and a lot of projects, as Michal mentioned, but also a lot of instrumentation for our work. And now I'm going to introduce you our 6 years old effort to integrate analysis of multiple contaminants into single procedure. And it was within the frame of Confidence project, and the work package I want to introduce was POP's work package, and as you will see, there were many compounds and many efforts to improve it. So what we can see, we were willing to introduce simple method for food contaminants, and there were several requirements to have the method very fast and simple, to decrease use of chlorinated chemicals, of course, and also have good performance characteristics which are needed to comply with regulation. And at that time, it was 2006, the very challenging technology was GC times GC coupled with TOF. That was the start, and you will see we end up with another challenge in instrumentation. Okay, the target compounds. So there are many requirements for regulation, and chlorinated compounds like PCBs or brominated flame retardants, and also 16 or 15 plus 1 PAHs were our list of target analytes. So this is where we started. And at that time there was regulation with requirements for LOQs and the other performance characteristics we had implemented in the target performance. But during the time there were some developments, and improved LOQs were required in the meantime. When we started, the state of the art was like that. It may seem a little bit complicated, but when you start with our target compounds, with PCBs, PBDEs, and PAHs, and when you make a review of approaches, you would agree that there are really many. Regarding extraction with SOX-LED and pressurized liquid extraction and so on. Regarding cleanup, again, a lot of approaches in different laboratories. And when I continue, then the final determinative step, again, may be HPLC for PAHs and different versions of GC for chlorinated stuff. So this was the state of the art where we started. When you go to real-life laboratory work, giving example of that time of our approach, we had accredited methods for different target POPs. However, with the exception of this SOX-LED extraction, at that time we went through different pathways, and we ended up with different chromatographic approaches. Moreover, for planar PCBs, we had a special method apart. So it was really, as is pointed here, a lot of labor, a lot of time demands we had spent on these monitoring programs which were targeted on these POPs. And now I am skipping our period of development, and actually the essence of our successful project was the flow chart which you can see here. And the flow chart is very different even from that what was introduced by Jeff. Because what we do at the beginning, instead of desiccation sample, this was our matrix at the beginning was fish tissue or seafood. And at the beginning, instead of desiccation, you add some water to your sample, you add some salts, and you apply something what you may know as catcher's procedure. Contrary to original catchers, we didn't use acetonitrile, but we used ethyl acetate as the solvent. I will show you, we tested both approaches, but this one was better. And then, of course, you have some fat in your extract, in ethyl acetate extract, so you have to move to some small SPE. And at that time, at the beginning, we ended up by GC times GC of MS. That was the start of project. And you also may notice the comments I gave here, the sample throughput using this approach was enormously improved and increased it was really a pleasure for the lab to have that. I will go into the details, but there are some operations in detail shown here, and you can see we add some water, we make some shaking, and at the end we centrifuge, we separate organic and aqueous phase, and to maybe even at that time our surprise, all the analytes were in there, in the final extract. So, and now just a small skip off, because whenever you develop method like that for fish or biotic matrices, of course you have to fight with fat in your extract. Jeff already mentioned in the morning, fat is the key bulky co-extract which has to be removed. And to do that, to monitor fat content in your extract, you may have some gravimetry or some approach, and I want to show how helpful is ambient mass spectrometry, which was helping us to check in real time, actually in few seconds, the amount of fat in our extract. So just to tell you what's that, what I have in mind, we are working with DART, connected with exactive thermo instrument, and the principle of that is that you desorb. Maybe it's better to move to next slide, just to show you how DART looks like. I will not go into the details, but here in open space you put your sample. This is in ambient atmosphere. It is interacting with helium excited atoms, and here is entrance into mass spectrometer. So it is in open space, contrary to Maldives, for example. Well, and the principle is saying in brief is desorption. So your compound, your analyte has to be thermodesorbed, and of course you have to have some ions, and that's all. And regarding instrumentation, this in 2007 we started with old medium resolution gel instrument, and now for many other purposes, not only for that one I'm showing here, we use Orbitrat with DART attached. And of course we benefit on high resolution which can be achieved. Okay? And now, what is the benefit or advantage of using Orbitrap is shown here, and specifically at this track. This is the pattern of triglycerides, lipids. And you can see different approaches we used for cleanup, and using very simple silica column for rapid passing the extract through, our lipids disappeared. And this is something what you just take a glass stick and you put it in front of mass spec, and you don't see anything in this case, absence of lipids. And if you use another approach, you can see there are either a lot of or residual lipids. So this is really very helpful to work with them. And this is another example of cleanup efficiency. And again, you have lipids here, and you can see how efficient your cleanup is. So this was really perfect. Okay, of course, at the end, I'm talking about integrated sample processing. That means at the same time for PAHs, PCBs, and brominated flame retardants. And here is performance, which you should appreciate because recoveries are in the required range, means above 70%, and also repeatabilities are very good at this low level. And here are the LOQs obtained at the time by GC times GC of MS. Okay, this is also a demonstration of accuracy because we needed to demonstrate that the accuracy is good one, and this is analysis of certified reference materials, matrix reference materials documenting good accuracy of this sample prep procedure. Just few examples on chromatography. This is when we started with GC, one-dimensional GC of MS. I should say that these files are very, very huge. And if you work with GC times GC of MS, your files are 10 mega and more. And you can imagine still the software is not so perfect to enable easy processing. So therefore, we started with one-dimensional GC of MS in electron impact, and then we published the paper, which you may read if you wish. And then, when we could see that the sensitivity, the LOQs, are not as low as we would like to have, we went to GC times GC to improve performance. Okay, so the GC times GC, what was the mission of that? We needed to improve chromatographic resolution, of course, and obtain detection limits, and also because the sensitivity is not so at that time, or at that instrument we used at that time was not so good one. We just also had to play a little bit with injection technique. So that was our another goal. And this is what you have to do. You have to think on different setups, and you have to optimize a lot of parameters. It takes really a lot of effort. In any case, this is somehow rewarding. As shown here, if you combine two orthogonal columns together, you can see really a substantial improvement of your detection limit. And the cause is that during the transfer of your L effluent from one to the other column, cryocompression occurs, and your peak becomes again narrower, and you can see, depending on compound, but let's say by one order of magnitude, the compressed peak shows better signal to noise ratio. So that is the outcome of your effort to work in GCGC. Okay, but again, reminding you, our set of analytes was a lot of different compounds, brominated compounds, chlorinated PAHs. So we had to go through testing a lot of columns combination, and at the end we found the best one, because the critical parameter is coelution of some compounds which cannot be spectrally resolved. And this is just an example of the outcome and what you would expect. You have such type of chromatogram with PCBs, PBDEs, and PAHs at the end. And this is a real life sample, for example, from Elbe River. Unfortunately, with a lot of positive spots, which are the analytes, impurity analytes in there. And also with pHs, this is even more critical because, as you know, in electron impact, pHs don't have too much fragmentation, and what you have to do is to have good chromatographic resolution. So, for example, for smoked trout, we have to do a lot of combinations to improve separation, like I will show here. We played with a lot of columns and critical groups. I don't say pairs, but critical groups. And at the end, we managed to find a solution for them. Okay, and I will not go into the details, but still, it is always difficult because when you combine the columns, one pair is separated, the other one not anymore. So this was the PhD student's work he spent. Okay, and again at the end some demonstration of certified reference material which shows you that your work is valid. And now I had a comment on the need to improve sensitivity, because that was the parameter which, when using this TOF detector, was needed to improve for very low detection limits, which we aimed at. So we had to increase our injection volume, and you can see this was our target, desired LOQs. That was reality. So somewhere yes, and somewhere we were a little bit above. Okay, so at the end, we were unable to meet this desired LOQs for some compounds, and for the rest we were close to or below. And at the bottom of slide you can see what was our problem at the end, in spite of increasing injection volume by PTV. Okay, so this is the paper PhD student submitted. We will see whether it goes through. And now I'm coming to the end of story. So as you could see, indeed, GC times GC, TOF-MS, very attractive technique. And as everything in our laboratory world has benefits and limitations, in our case it was a lot of big data and maybe sensitivity. And at that time we had a new possibility to work with MSMS. I should say that in 2006 or 5, when we planned the project, MSMS was not routinely or was not easily available at the market. And in the meantime, we got possibility to work with thermo instrument, which enabled us to expand the method. So when I say expand the method, you can see that in the next step, at the end of project, we expanded the scope by many compounds. In addition to simple small group of PBDEs and other compounds, we added, for example, for pHs, not only EU pHs, but also EPA pHs, that means those. We also added, and it was a big effort, within AOAC validation study, which we took part in. We added also on request of AOAC some alkylated species, and the same we put emerging brominated compounds on the list. So now the method, sample preparation method, which I introduced, is this one. Trying to get our task was what is the performance when using this new sample prep for those compounds. That was the task. Okay, so at the beginning we had to absorb the drawback that using silica we cannot analyze those compounds. That was reality, but when you take the huge list of compounds, that was the small compromise we had to admit. And then we made some optimization of the chromatography using this very simple new sample, catcher's-like sample prep. Okay. And then this is for, because this project is still ongoing, so I cannot make conclusions for incurred samples, but incurred samples, this is issue related to sample prep, not to the instrument. So you can see MS performance for here it is for PCBs and for some organochloride compounds with good outcome. Then we have still some tasks in front of us. From this big list, some compounds need to have more care. And you understand it, those who are working with brominated compounds, 209 and these very heavy species, they need to improve chromatography to make it shorter and to take some special approach. And the same is true for those brominated emerging flame retardants, which are very heavy, and again we need to go to higher temperatures and faster run. Otherwise, all the rest was okay. With pHs, we spent a lot of effort because the sample prep was the part of method which will be now official AOAC method, the sample prep, which we are very much pleased with this outcome of project, and we spent a lot of effort to optimize pHs. And you can see the students were very happy because they managed to have very good data for pHs in this MSMS determinative step. Okay, so I am coming to the end. Within the project, I didn't mention all, but different large range of approaches was tested. Actually, when we entered the project, our main mission there in POX work package was GC times GC top MS, but it was not only our opinion, but all the people which we collaborate with at the end come to conclusion that for them, from practical point of view, it's much more challenging to work with MSMS, with target analysis, and the data I showed you were for this nice instrument. And you can compare also the outcome. This is these are performance parameters, which in many cases are better or equal to GC times top MS, what was the first idea. And I should say that the project is not still closed, and we believe that for those compounds we still have some not smile, it will improve. And at the end, I want to conclude with some statement that we were able to introduce new method, sample prep. You can read on monitoring on GCMSMS, how did it improve our approach, and so on. This is what we will continue in. And I also mentioned this new technique, ambient mass spectrometry. Actually, we have a lot of interesting work, which is also assisting residue analysis or trace analysis with ambient mass spectrometry. So this is invitation to workshop in June, which is co-organized with our colleagues from Thermo, because we work with Orbitrap, and this is our main tool for ambient MS. And this is RAFA associated event, and for those who are interested, and I can send flyer unless they are not on our target list. Thank you very much for your attention.